Hello, good morning, everyone. Today I'm here to present my project, which is stock market price prediction using big data analysis using PySpark. In this project, we'll be using PySpark, Hive, Scoop, HDFS for storage, Matplot for data visualization, and some machine learning techniques. Let me walk you through the data set. This is our news data set, and which I'm going to explain. You can see we have the links from where we got them and the date, the headline, and the content of the data set. And here I'm using Google Colab, and I'm importing the files from the drive. As you can see, I am mounting the drive, and my data set is in this folder in the drive, so I can directly take from it. After that, I'm installing PySpark. Once the installation is done, I would create a PySpark session. For this, I will import Spark session from PySpark.sql. Then after, I will create and start the PySpark session. Then after, we will import all our needs, like we'll import all the functions from PySpark.sql.functions. Then after, NumPy and Pandas and Matplot library for plotting, for data visualization and plotting the predictions and all those things. First of all, we do the sentimental analysis on the Apple News dataset, which I have shown you earlier. As you can see, I am storing the new dataset in a new data frame and just renaming the folders, renaming the column names like link as URL, date as timestamp, and headline as headline, content as content. Here we are showing the data set. Just a quick overview, like we have so many rows, but we're only showing the top 20. And the next step would be we only take the required, like in this four, we only required the date and the content, the headline and URL are not useful to us. So we will just drop by using like calls to drop, like it drops the columns which are not required, and we will do that. And you can see an overview, like we only have date and content remaining to are removed. And this gives the total count of the number of data sets in the, sorry, number of columns in the data set. And after this, we do the data cleaning. And for doing data cleaning, we are defining UDFs in Python, which are basically user defined functions. And the first UDF does is remove extra spaces, like all the extra spaces in the content are removed. And the next UDF removes the punctuation marks. As you can see, whenever it finds punctuation marks, it just removes it. Then after, we download the NLTK resources. NLTK resources are nothing but natural language toolkit in Python. And we download Puncti, which is basically for tokenizing. This is for stop words. And the next two are for lexicon analysis, which helps us in sentimental analysis. And after downloading our requirements, we'll go with tokenizing, tokenizing by using the downloaded Puncti. And then after, we define another function which helps to remove stop words. And this uses, as you can see, as we already told, we use stop words from NLTK. And then after, we limitize. Limitize is nothing but we use wordnet limitizer, which helps in like removing all the unwanted words and just the words which impact our sentimental score. Like for example, for few words like good, bad, average, all those words will come under wordnet limitizer, and sentimental analysis, semantic analysis applied on that, and that helps in giving the sentimental score for us. And the last predefined method will be, sorry, last user defined function would be the sentimental score one. And this takes output from the last function and uses here to predict the sentimental score. And like we define the user defined functions over there. Now we are using them, as you can see. And we have, as we earlier defined the user defined functions over there. Now we will use the user defined functions, and we'll take the outputs in the new data frames, as you can see. the first one removes the extra white spaces, which uses a function we have defined in the top, and the output of this is stored in a new news data frame, and this data frame is used and the next user defined function, that is space remove punctuations, is used here, and then after it's stored in the news data frame. Like for every iteration, the news data frame will be updated based on the function we are used earlier. And the next one will be tokenized, which tokenizes. Then after we use the remove stopwords function, then the lemmatize and sentimental score. In this way, we predict the sentimental score of the particular data set. And here we can see we will show the news data frame at the end, and here we can see the date content and how it would be after space removed, how it would be after cleaned, how it would be tokenized, how it would be after stopwords removed, and in the end we can see the sentimental score of the particular data. Thank you, and the remaining part will be explained by teammate Ashrit.
Hello, everyone. My name is Abdul Suhan, and as my teammate explained about stock market and tools used in the project, so I'm going to continue with the stock price prediction. So, so stock price prediction, like as we know, the stock market is known for being volatile, is extremely challenging because of multiple micro and macro factors such as political, global economics conditions, unexpected events, and companies' financial performance. So it like if we consider like predicting the stock market, there are like many types, mostly two types of events. So I'm going to continue with the stock price prediction here. Uh, so first of all, I have uploaded the data of Apple stock price of its historical data from around 1980. Yeah. So as we can see, I have defined with a proper schema and renamed all the fields as required from here. Next, I have combined the two data sets, which are sentiment score and uh, price data, price data of Apple. Yeah. So for merging of these two sets, like because in order to make it sentiment score available for all the dates, for that reason I have combined both the data sets. Like if you ask me what is sentiment score, like sentiment score is a algorithm that accesses the transcripts of spectrum of positive and negative values, and if there was like no event, then the sentiment score will be zero or null. Like even if you want to predict the stock price, then we need to consider the no time free variables such as open, high, low, etc. And this is the whole data frame of the final of Apple stock price. And if I go to next topic, which is known as exploratory data analysis, like I have defined the count function. Like it is used to see the how many observations we have like seen. They are around like more than 10,000, as you can see here. And in order to find the first date and last date of the price data of Apple, like have write the function for it too, which is on 1980, as you can see here, and the last date is 2021. After that, we need to check if there is a data which is missing or null. So in order to do that, I have like we need to check every column, which is open, high, low, close, adjacent, close, volumes, and sentiment score. Uh, After that, if there is like no data sets missing or nulls, then we can continue. As you can see, there is no missing data or null factors. There are 0 for everything. Then we need to move to plotting itself. This is the like whole program for it. And as you can see, this is a plotting of Apple stocks from 1980. As we can see of freezing time, as you can see, they are like the price hiked at around 50 to 55. That's it. Thank you. My friend gonna continue about Dickey-Fuller test.
Uh, Hello guys, this is Gautam, and I'll try to explain the Dicker-Fuller test that we've performed here. Basically, the Dicker-Fuller test is a common statistical test that we use to check if the certain times, any certain time series are either stationary or not. Here we are trying the Dicker-Fuller test to check the stationarity of the time series data. We have observed that the time series data is not stationary because the value of p, the probability value, is greater than 0.05. And we are also calculating the lag, which is the difference between the closing prices. And because ultimately we're trying to find trying to predict the closing price. Um Here we took the first lag, which is the closing time of the previous trading day, which is lag one. And we also calculated the difference between the closing prices of the previous day and the current day. Uh, that's the closing difference one that we're observing here. And we are gaining these values to check if there's any hampering with the Dicker-Fuller test. In the results, we can see that the value of P, I mean the probability value, is less than 0.05. So basically, according to the null hypothesis, we can reject it, and we know that the time series data is now stationary. Uh, Also, we there's a concept called the rolling mean. It could be a 30-day rolling mean, 50-day rolling mean, whatever. The traders use this to predict the uh, stock price ultimately. This is a technical indicator that smooths out all the price trends by filtering out the noise and unnecessary data from uh, random short-term price fluctuations. These rolling mean is also known as moving averages that can be constructed in several different ways and employ different number of days for averaging the interval. The most common applications of the rolling mean are to identify the trend direction and not to determine and I'm sorry to determine support and resistance levels. Um, uh, these are the things that we can get after calculating the rolling mean of 30 days. And also, these are the things that we need to perform before going to the feature engineering part that we've performed. Uh, we can observe that the original data is not stationary from the graph here. And yeah, and the difference after calculating the differences of the lags of the previous time and the stock price, we can see that the time series data is now stationary. Uh, and we are also calculating the lags of lag 1, lag 2, lag 3, which are consecutive differences in the stock price and time of the previous day's closing period. Also, and these things are performed before we go to the feature engineering part. And in the feature engineering part, we observe that we are also calculating the respective lags, like I told, and we are using the signum function to you know to clearly display the uptrend and the downtrend of the day. The positive and negatives, which show that whether the stock is in uptrending or downtrending. And these are the values that we can observe from the data we've given. And these are the closing lags.
Hi, I'm Ashrit. I'm going to explain the modeling and linear regression parts of stock price prediction project. Coming to this part, we are creating labels for machine learning, and we are creating a model for the machine learning model so that it can be used for training purposes. Here we are using the forecast of past 3 days price in order to predict the future value. See, if you want to use other days like 3 or 4 days, we can simply replace the value of 3 with 4 or 5 so that it takes the past 5 days prices to predict the future prices so that it will be more accurate. And here we are using the windows that have been generated in the feature engineering process above. And coming to the and going to the next step, that is feature preparation for the vector. And that here we are using the values of the closing dates and the difference between the closing dates of past 3 days price and the sentimented scores generated above. Here we are using vector assembler in PySpark that combines a given list of columns into a single column, vector column, so that all the column features are combined into a single feature called features here. These all columns are combined into a single feature called features. This can be used in the while we are training the model using the data set. And this is a schema that we are combining all these parameters into a single parameter called features. And this is the data set we are using. This is a Apple stock price of opening and closing from the past 20 years. And the news of Apple stock price for like 3 or 4 years. This is the data set we are considering for the model, for our model. And we are splitting the ratio of that data set into 70:30. So that the 70% of the data set is used for testing purpose, training purposes, and the remaining 30% is used for testing purposes. As you can see the size of the training and testing data set here. And going to the linear regression model, in the most simple words, linear regression is a supervised machine learning model which finds the best linear relationship between the independent and dependent variables. And this model main aim is to find a best fit and the optimum values and coefficients such that the error is minimized. Here we are using inbuilt PySpark library to import the linear regression model. We are using the input parameters from training dataset and setting number of iterations the model has to go through and the features. And this is a feature column that we have generated above. And this is a command used for training the model. And the trained model of and the model and the trained model and the predicted values of trained dataset is loaded into this one, and the test dataset is loaded into this one. And these are the top 10 rows of the prediction. This is a original closing price, and this is the predicted closing price of that stock. And this is a graph for original price and predicted price for training dataset. As you can see, the original price is in green color and the predicted price is in red color. As you can see here, the green and red lines are almost or coinciding with each other. That means the predicted values and the original values are almost the similar. This is the predicted values for the closing price on test dataset. And this is a graph for that. As we can see, the original price and the predicted price are almost coinciding for the test dataset also. This means the model is much accurate. and we are using RMSE as an evaluation matrix. Most beginners in machine learning do not bother about the model performance. The machine learning model cannot have 100% efficiency, otherwise the model is known as biased model, which further includes the concept of overfitting and underfitting. This is necessary to obtain the accuracy on training dataset, but it is also important to get a genuine and approximate result of unseen data. That is the testing dataset. There are different metrics such as mean absolute error and root mean squared error. Here we are using root mean squared error. It shows the root of difference between actual and predicted value. We are using inbuilt regression evaluator to find the value of RMSE. This is a regression evaluator we are importing from PySpark. And this is the values for training and testing values. As you can see, this is very, very low. That means the accuracy is high for training, and it is almost 80% accurate for testing dataset also. And we have used Hive and Cloudera for the dataset, for analyzing the data and seeing the statistics of the data. Statistics of the data, and this is this stocks new is important using the Scoop is using Scoop. We use Scoop to import the data from my SQL to Hive, and then we have analyzed the data set such as the highest and lowest and the highest volume of the stock and the price. That's it. Thank you.